wormholes, particle physics, extra dimensions. Are the wonders of so-called reality really what they appear to be? Or do we exist in an elaborate hologram? Is our universe the result of random activity or the result of intelligent design? If a creator was involved, can we discover him through our perception of divine order? This is Into the Multiverse with Josh Peck.
Remember Stranger Things on Netflix, that show? If you haven't seen it, it's a pretty cool show. You might like it. But in the show, there was an alternate universe called the Upside Down. Well, what if I were to tell you that there actually is a type of opposite universe that actually exists within the same space as our own? That is going to be the topic of today's show. I am excited about this. With me in studio, Christina Peck. How are you doing?
I am still good. I'm good.
Good.
Really good.
I'm doing good too.
Good.
And of course, you're lovely and beautiful as always.
Oh,
Usually
thank
I
you.
address you in that manner. I wouldn't want the audience to think that something was wrong because I didn't introduce you as my lovely, beautiful wife for one episode.
For one.
But everything's good.
Yeah, everything is great. I'm excited to be here and talking about this.
I am too. I'm always excited about this, especially doing these kinds of shows because we actually have a really awesome guest, a fantastic interview. Enough good could not be said about our guest today. Dianna Cowern, she's known as Physics Girl on
Yes.
YouTube,
Yeah.
and you actually interviewed her.
I got to interview her. Not first time I interviewed, but first interview in a long time.
Well, since the pregnancy.
Since the pregnancy.
Yeah.
Yep.
Yeah, and the interview came out great. You did a phenomenal job, of course, as did Dianna, and it's a really cool interview. So we're going to get to that a little bit later. Before we do, though, if you haven't had a chance to do so, go ahead and subscribe. You can subscribe if you're watching this on YouTube. There's a little subscribe button in the corner of the screen. You can subscribe there. Where else can people find us online?
Okay, you can find us, as he said, right here on YouTube, youtube.com/Into the Multiverse. You can find us by going to skywatchtv.com, and you can scroll down, and on the right-hand side, there will be a banner with Josh and I on there, and it says Into the Multiverse. If you click on it, it will send you right here. And also, if you have Roku, check us out on Roku under the Skywatch TV channel.
Yes, definitely. All right. Well, we are talking about the how everything in the universe seems to have an opposite, which is interesting. And one of the most classic examples, we actually have a few of these. If we have time, we'll get through all of them. But the classic example, probably the easiest one, is matter and antimatter. Mm-hmm. There's actually a thing called antimatter. It's not a myth, it's a real thing. They actually have created this and stabilized it in the lab before. But basically, it's you have normal matter, which everything is made out of, but then you have antimatter, which is actually just about the same in every way, except it has an opposite charge.
Yes.
And that's kind of the cool thing about matter, is that it's charged in a certain way, but antimatter is charged the opposite way. Mm-hmm. So when they come into contact, they actually
cancel each other out.
They cancel each other out. They annihilate. Mm-hmm. They cease to exist. And so it's weird to think about how much damage antimatter could actually do.
Yeah.
But again, they've been able to stabilize it.
Yeah.
And essentially grow it in the lab.
Which is weird.
Yeah.
Growing antimatter.
Yeah, but that's the kind of world that we live in. Something else that's really interesting, and we just throw out the matter and antimatter as an example, but we could actually talk about black holes and white holes.
Yeah, this is something that's interesting. So a black hole, it nothing can escape it. Mm-hmm. It sucks everything into it. But then there's a white hole.
Yeah.
What the white hole is the opposite. It expels everything out and you can't get to it.
Yeah.
So we were talking and I had brought up, so if a white hole or if a black hole sucks everything in, doesn't it have to go somewhere?
You would think so.
So if what the white hole is, do you think that's the other side of the black hole?
It might be.
Because it expels everything out.
Yeah, it might be. Now, as of now, white holes are completely speculative.
Right,
They're
it's
hypothetical.
Hypothetically, but I mean...
they've never been observed, but there seems to be some mathematics to support that they probably do exist. I mean, it wasn't even that long ago that black holes were completely speculative as well. They were hypothetical things. Nobody knew for sure if they were really out there, but now we do.
Yep.
So this might be the same case with white holes. Now, what you brought up too is interesting because black holes suck everything in, even time, light, matter, everything. Once you reach the event horizon, there is no escape. There's no amount of energy. You're doomed. There's no amount of energy that's going to get you out of there. And the common theory is what happens is when you go into a black hole, you're kind of crushed into the singularity. But there is a problem because with the singularity, the way that it's described is it's an infinite. It's a point in space that's infinite mass, and you can't have infinite mass.
No, you can't. You can't have
so that's a problem.
Infinite anything.
Exactly, you can't. Not at least not in physical reality. So,
right.
So that's a problem. Now there have been. And also, there's another problem with black holes is where does the information go? Because there's this thing called, I believe, the information paradox, which basically says that information can't be destroyed. It's got to go somewhere. So even if you burn a sheet of paper, the information of what that paper was doesn't disappear too.
No, it's everywhere now.
You still have you have ashes and the smoke,
yep.
So the information still exists in some form. Well, it's with a black hole though, not so much because everything's crushed down to the singularity. So actually, Stephen Hawking developed his theory on Hawking radiation, where around the event horizon of a black hole, stuff might get burned off and kind of radiate out. So that sort of solves the information paradox, sort of, but even that has issues with it, which Stephen Hawking even admits to. So the interesting thing is a white hole might be the answer to all these problems with black holes, because where does the information go? Maybe it gets expelled out of a white hole. Now, of course, this would have to be with stabilized black holes.
Yes.
Because black holes, as we understand them now, they have this weird infinite mass thing, which again can't, But
it just can't be.
If a black hole is somewhat stable, and there are theories that talk about the stabilization of black holes, basically if a black hole spins fast enough, you have enough centrifugal force that's pulling it out so it's stabilized. It's kind of like the balance between the Earth and the Moon. The Earth and the Moon's gravity are pulling each other closer together, but the Moon spinning around the Earth creates centrifugal force that's pushing it out, so eventually you reach equilibrium. Black holes might have that same aspect. If that's possible, you could actually traverse a black hole, possibly. But again, where is it going to go? And white holes might be the answer. So like you said, a white hole is something that expels everything out.
Yes.
You can't get to it.
Right.
You reach a point where the force, if you were approaching a white hole, all the light and matter and probably even time, that's a whole other layer to this, but even everything that's being expelled out, you have a lot of energy coming out at you. There's going to be a point where no matter how much energy you have, it's not enough to break through, so you could never really reach it.
I know, they describe it as like going up a steep hill, and the closer you get to that arc, it's harder and harder. You have to push harder and harder to get there, but the only difference is it's impossible to get to.
That's right. It's impossible to get to. So this might be the answer that physicists are looking for to explain black holes and all these paradoxes that come out, like infinite mass and infinite time and all these strange things. White holes might be the answer.
Very interesting stuff.
Yeah, it is. Now, the time thing's kind of interesting, too, because when you approach a black hole, time for you actually changes. Now, the way that it works out is somebody viewing from the outside, they would see you start to enter the black hole, but you would slow down and never really reach the event horizon because time is actually operating differently.
Yeah.
For you, though, time in the universe is speeding up to the point, for you it's slowing down or whatever, but the universe itself would be aging faster and faster and faster the closer you get to this point of singularity. Now, I would imagine it would be the opposite with a white hole, where it's actually shooting out so fast things would be probably starting out at the speed of light and maybe slow down after that. But time would operate differently there, just in reverse. So it's,
I know we were reading an article, and it even says it had a reverse. It may have a reverse on entropy, which I still don't.
Yeah.
Because if everything's slowing down, approaching a black hole, and then would everything be speeding up? Vice versa.
Yeah, and that brings up an interesting point too about entropy. Is you can't have you can't reverse entropy.
Right.
You can slow down entropy, sort of, but that comes at a cost somewhere else. So black holes, that's like maximum entropy. That's like maximum chaos or maximum
and destruction,
disorder. Yeah. So the problem with white holes is, at least what this article said was, and I think what they're getting at, they said that white holes would actually, in a sense, reverse entropy.
But you can't really do.
You can't, and well, they say that that's one of the main problems with why white holes might not be possible. And I think where they're getting that is the idea, since a black hole causes maximum entropy, then a white hole would have to be opposite, some way. But I don't think that accounts for a stabilized black hole. If you have a stabilized black hole, you wouldn't have to have maximum entropy anymore. You could,
it wouldn't be as chaotic.
Yeah, you could have, theoretically, you could have things pass through it, at least light, maybe not anything beyond that. So in a sense, white holes might actually be the answer, but we'll have to wait and see. Again, black holes were completely speculative not that long ago. White holes might turn out to be the same.
Yeah, that's pretty interesting stuff. Another thing that we can talk about is gravity and anti-gravity.
Yeah, and that's really interesting too. This actually kind of opens a can of worms if our government or the governments of the world have developed any kind of anti-gravity technology. Normal gravity is kind of mysterious. We don't know a whole lot about it. At least the public doesn't. Maybe they know more. But
get into this a little bit of conspiracy here.
Why not? It's into the multiverse. We can go there.
Conspiracy theory it up.
It's fun. But gravity in itself is really mysterious. We don't know a whole lot about it. It's actually probably the one of the four forces that we know least about.
Yeah.
But it is there. It exists. There's a gravitational field, which means there's a graviton particle. Now, we have detected gravity waves, which is really exciting. But we have yet to observe a graviton, to actually physically record a graviton. But if there's a graviton, maybe there's a type of anti-graviton that reacts in a different way. Now, this wouldn't be antimatter, because fermions are matter particles, and bosons are force particles. A graviton is a force particle. It's a carrier of force. But maybe there is a particle that's an anti-graviton, that maybe repels instead of pulls together.
When we talk about anti-gravity, or talk about zero G's, even on a roller coaster, they will for me, I love roller coasters. You hate them.
I hate them.
But I have experienced that zero G force, which you do on a roller coaster. They will tell you'll be experiencing zero G effect, And when you go up and then over and then up again, you lift out of your seat. A little bit, and that's just the zero G effect. And I mean, if you go on the vomit comet, I've never been. I'd like to. That'd be kind of cool.
You're insane.
I think that'd be really awesome, going up the parabolas and the arches, and you are actually weightless for a period of time and getting that effect. I mean, even they made the movie Apollo 13. Those weightless scenes are them on the vomit comet, which I think is absolutely amazing. And so I don't know if anti-gravity and zero G's would be even anything we could discuss.
Well, I mean, it brings up an interesting point, because as far as we know it, like we talked about the Earth and the Moon, there is an opposite to gravity. It's not technically anti-gravity,
right,
but there is an opposite to gravity, and it's the centrifugal force. But there's also expansion of the universe. There's a bunch of different things that is just completely mysterious and we don't know anything about. But I do often wonder if maybe our government or the governments of the world if they do have technology like that and they don't tell us. I mean, I saw this video on quantum locking, which is basic. It's a kind of anti-gravity. It's not anti-gravity in the sense that it cancels out like the force of gravity.
Right.
It's kind of a workaround, but it's called quantum locking. And basically you put this piece of metal in liquid nitrogen that's wrapped in plastic, and you put it on this track, and it quantum locks in those 3 dimensions of space.
With the liquid nitrogen and everything, yep.
Yeah, it makes it superconducting, but it locks in that space, and then you can move it around this track and it'll actually hover. People can find that online. I did a presentation about it in Colorado earlier this year because that is cool. The weird thing is, it's available for the consumer. You and I could buy one of those. And
we wanted to buy one for your presentation, but we never.
We didn't have.
We didn't have the finances at the time.
Yeah, because it is like a couple $1,000s or something. Maybe we'll buy one for the show and do a whole show on quantum locking.
That'd be really fun.
Yeah, that would be awesome. But it's a really cool phenomenon. So there are things like that do exist that are even available to the consumer now. Fascinating stuff. Okay, we're going to be talking about more opposites, and we're going to get into our interview with Dianna Cowern, physics girl from YouTube, right after this.
You can save the life of a child in desperate need of a family. Children in foster care are at high risk for drug and alcohol abuse, early pregnancy, violence, and jail time. And they're often in foster care because their birth parents just weren't up to the job. That's where Royal Family Kids steps in, showing these kids love, compassion, and the model of what a loving family looks like. And most important, by being family, we can share the gospel of Jesus Christ with them. At Skywatch TV and Whispering Ponies Ranch, we're proud to partner with Royal Family Kids, and you can help through your financial gift. For your donation of $25 or more, we'll send you 2 books, From Despair to an Heir by Wayne Tesh, the founder of Royal Family Kids, plus A Legacy of Hope, compiled from 25 years of stories from Royal Family Kids camps. And we'll include the DVD of the film Camp, featuring true stories from real-life campers at Royal Family Kids camps. To donate, call 844-750-4985. That's 844-750-4985. Or log on to skywatchtvstore.com.
Welcome back to Into the Multiverse. Glad that you are back with us. In just a minute, we're going to be doing showing you an interview that Christina did with Dianna Cowern. We have a couple more opposites we could quickly go through, and then I do want to get to this interview though. But Planck length and infinity, these are complete opposites.
Yep.
We actually have boundaries of our physical universe. And for regular viewers of the show, they're going to be familiar with this already because we have talked about it a lot. But there's a limit to measurement, just like there's a limit to time, how small you can get. And that seems to be one of the boundaries of our entire universe. You can't get smaller than the Planck length. You can't cut a Planck length in half.
Nope.
Otherwise, actually, physicist Lisa Randall, she wrote in her book, Warped Passages, she wrote in there, what would happen if you were able to probe the Planck length is you would create a black hole, because it would take so much energy to do that in such a small amount of space.
That's so cool.
It is. It would create a black hole that would completely destroy everything you're trying to work with.
Right.
So there's a boundary to reality, but there's also a boundary of largeness, which is infinity.
Yeah, and you can't have infinite mass.
Even mathematician Carl Gauss said that infinity is just a way of speaking, and he actually protested against the use of it in math.
Right.
So when we talk about the boundaries of our universe, there are some physicists that believe, and some scientists and cosmologists, there are a few out there that believe that the universe is infinite. But I personally don't.
I don't either.
And the reason is it's all based on percentages. We exist in a certain percentage of the universe. We don't know what percentage that is. We assume it's very small. But let's say, just for sake of argument, it actually would be way smaller than that. But let's just say that it's 1% of the universe. Again, it's not. It's way smaller than that. But let's say we existed in 1% of the universe. Well, how big is 1% of the universe if the universe is infinite in size? If the universe equals infinity, what's 1% of infinity? Infinity.
Exactly.
1% of infinity is still infinity. Our solar system is not infinite.
It's not infinite.
The Earth isn't infinite.
No.
I may have put on a few pounds over the years, but I'm not infinite.
I'm not infinite.
So, just the fact that we exist in a certain percentage of the space that reality is composed of, to me says you can't have a true
No.
infinity.
Looking back, even 20 years ago, they thought that the universe may be infinite. And
Well, even Albert Einstein thought that.
Yeah.
And he even went as far as to say later that it was his biggest blunder.
It was biggest blunder, exactly. I was going to get to that. But now they're even saying that there might be even a curve to it, like a bowing.
Yeah.
For it it might be a three-dimensional sphere of some sort.
Very well could be.
I mean, it could be that because everything, with the gravity and everything turns into a sphere. It's like a bubble.
Yeah. Speaking of bubbles and anti-bubbles.
Anti-bubbles.
I want to get to this interview. Earlier this week, a couple weeks ago, Christina did a Skype interview with Dianna Cowern, and if you're not familiar with that name, she's Physics Girl on YouTube. Make sure you subscribe to her channel. There's a link in the description below this video, linking to her channel. Make sure you subscribe. She's got a lot of awesome videos about physics and science, and that makes it fun for laymen like you and I. And so I think that you'll really enjoy it. And make sure that you check Into the Multiverse YouTube channel because we actually have the extended interview. What you're about to see is just a piece of the full interview because we only have limited time for shows like this. So make sure that you go to the YouTube channel. You can see the whole thing, and it's a phenomenal interview. So here you go. Check this out.
Hi, Dianna. Welcome to Into the Multiverse. Glad to have you here.
Yeah, thank you so much for having me. I love the name of your show.
Oh, thank you. Thank you. Well, for those who are not familiar with you or your work, can you tell us a little bit about yourself, your YouTube channel, how you got started, and why you picked the field of science that you are in now?
Yes. So my name is Dianna. I'm better known on the internet as Physics Girl, slowly losing my identity to that name. But I run a YouTube channel with PBS Digital Studios called Physics Girl. It's all about physics. It's kind of fun experiments, like little things you can do at home, but then like just questions about the universe that I have, like what can a black hole evaporate, or crazy things like that actually happen. And I chose science just because it's like the curiosity. It really is the curiosity field. Like it's whatever question you have, science likes to go and find the answer. Whether it's biology, looking deep inside the human body, or physics, which is my personal choice, ask questions about the entire universe. So that's why I like science.
Awesome. Amazing. In one of your videos, you describe a way to do advanced mathematics in a simplistic way. Can you explain the method and tell us the inspiration behind it?
Okay, so that one was a lot of fun. So the math tricks video was a video trying to kind of take all these little daily math things that you have to do, make them a little bit easier. So one is tipping. There's 5 different tricks, but that was just one of them. For the tips, I like to take the amount that you have. Say it's $20, and then for every 10 that you have to pay, you think 20% would be about $2 for every one of those 10s. So $20 would be 4. So $4 is your tip. That's how I think about tipping. And then I went through a couple different math tricks like that, like multiplying 9s using your fingers and why you do that, and multiplying 11s, all kinds of little simple tricks to make math easier. That was a unique video. I don't usually do math videos, and that was kind of it wasn't like a type of math you'd usually use in physics, but it was fun math tricks that I like to think about.
Yeah, we thought so too. We thought it was really fascinating, and I was thinking about bringing that up on when we did our interview with you. Very cool, very very exciting, and I think it's really important to get people excited about physics and math, and even helps the younger crowd in a way. A lot of people struggling with math. It makes it a lot easier.
Yeah, absolutely.
And we
physics,
really appreciate
physics
that.
Uses a lot of math. I think that's one of the things that makes people say, I was so bad at physics, I hated physics, which I hate to hear because physics for me it's like fun and exciting. But I think a lot of it comes from math and like not feeling completely comfortable with the math that you have to use for physics.
Yes. Yeah. Absolutely. I agree. In our show, we've talked a lot about antimatter, but you discuss anti-bubbles. What is an anti-bubble?
I do. Anti-bubbles have a really exciting name for a kind of humdrum everyday phenomenon, although I think it is still pretty cool. Antimatter is this sort of elusive matter that is not very common, and anti-bubbles are, okay, so a bubble is like a shell of liquid with air inside and air on the outside. An anti-bubble is the opposite. So it's a shell of air with liquid in the middle and liquid on the outside. So you actually make them every time you turn on a water faucet. You'll get these little shells of air inside the liquid as it's moving around. And they don't last very long. So they're not, people don't know that they exist as much, but if you put a little soap in some water and then you squirt water onto the surface of that soapy mixture, you can get anti-bubbles to form and kind of float in the middle of the liquid. It's fascinating.
That's awesome. Dianna, it has been an absolute pleasure having you here with us today.
Thank you for all the physics questions. Every time I do interviews, it's like, what's it like to YouTube? I'm like, no, I want to talk about physics. So that was great.
It's been absolutely phenomenal having you here, and thank you again so much.
I appreciate it. Thank you.
All right. Well, that was Dianna Cowern. What a phenomenal person.
She is great. She's really nice.
Yeah.
I like that she mentioned that she likes our questions.
Yeah.
Because she likes to talk about the physics. She's like, I don't care about my personal life. I just talk about physics. That's what I want. I want to talk about physics. Great.
Yeah,
we want to talk about physics too.
Yeah, I thought that was really cool. It's always fun to meet somebody who you can tell has a passion for this kind of stuff. It was like when we talked with Michael Stevens, Vsauce on YouTube. He's somebody that also really has a passion for this, and it makes it fun and exciting. And I love people like that. So a big thank you goes out to Dianna for taking time out of her busy schedule to
very busy
to talk with us. But I think we are just right out of time again. These episodes go by so fast.
Yes, they do.
But for people who this might be their first time, where can they find us online?
Welcome if it's your first time. If you stuck around to the very end, thank you. Don't forget to subscribe if you haven't already for more interesting, exciting videos to come. You can find us here on YouTube at youtube.com/Into the Multiverse. You can also find us at our Skywatch TV homepage at skywatchtv.com. You scroll down, and then on the right-hand side, you'll see a picture of Josh and I. And if you click on it, it will bring you here to YouTube. And also, if you have Roku, check us out on Roku and under the Skywatch TV channel.
Fantastic. Yes. And again, the interview that you saw in this episode was just a piece of a larger interview. So make sure that you subscribe to Into the Multiverse, and you can actually look for the extended interview Into the Multiverse exclusives with Dianna Cowern. You can watch the whole video. Make sure you do, because there's a lot of information packed in there that we just didn't have time for in this episode. But all that being said, thank you once again for joining us Into the Multiverse. As always, take care and God bless.